All right, so this is the notes for day 11. And we're going to be looking at some real world problems involving quadratics. And we're actually just going to look at this one question. It's talking about fish population in the ocean as water temperatures change. So we're going to kind of look at this one and know, hopefully be able to do every problem on the homework based off of what we talk about here. So here's the problem. It says the fish population in a certain part of the ocean, in thousands of fish, as a function of the water's temperature in degrees Celsius, is modeled by this function. P of x equals negative 2x squared plus 40x minus 72. So the first question says, what temperatures will result in no fish? Well, let's look at the equation and try to understand what it's saying. It tells us that P of x represent the population in thousands. And then x is the temperature. All right, so when it says what temperatures will result in no fish when the population is 0, all we're going to do is just set P of x equal to 0. So negative 2x squared plus 40x minus 72. All right, then I'm going to solve this. We're going to work through this one using algebra, but then I'll show you using Desmos how you could do this without having to do all the algebra. It all kind of depends on what's asked of you when you are doing your tests and assignments and stuff like that. Okay, so I'm going to factor out a negative 2. And when I do that, I get x squared minus 20x plus 36. So I'm going to factor what's in those parentheses if it is indeed factorable. And our factors of 36 are 1 and 36. Remember, these are just numbers that multiply up to 36. 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So what we're looking for is something that will multiply to positive 36 and add to negative 20. And so that's going to be negative 2 and negative 18. So our factors are going to be x minus 2, x minus 18. All right, now if we know that this has to equal 0, that means that either x minus 2 or x minus 18 has to equal 0, because the only way we're going to multiply these three things together, there's three things. There's a negative 2, an x minus 2, and an x minus 18. The only way we're going to multiply those three things together and get 0 is if one of those things is 0. So x minus 2 could equal 0, or x minus 18 could equal 0. So I'm going to solve these. X could equal 2, and x could equal 18. So the question is, at what temperature will result in no fish? Well, that's at 2 degrees and 18 degrees Celsius. So just to kind of get a sense of what they're saying here, if this is 0 degrees, here's 2 degrees, here's 18 degrees. Anywhere between 0 or 2 and 18 degrees, there will be fish present. Anywhere outside of that, there will be no fish. It's a sad day for your math teachers. All right, so what temperatures will result? 2 and 18 degrees. All right, and then it says, what temperature will result in the maximum number of fish? How many fish is that? So one thing we've learned about quadratics is they look like a parabola. And in this case, it's going to be an upside down parabola because the first number in front of x squared is negative 2. And we know that this parabola is going to cross at 2 and at 18. It's going to cross the x-axis at those points. So our maximum is going to be right in the middle of 2 and of 18. So the way we can figure out where the middle is it's just the average of those two. So you add them up and divide by 2. And that would be 20 divided by 2, which is 10. So at 10 degrees, what temperature will result in the maximum number of fish? this would be 10 degrees Celsius. And how many fish is that? So that's the trickier part, I think. Let's grab a new color here. And what we do is we take the original equation. So the original equation was negative 2x squared plus 40x minus 72. And we want to figure out what is the y value of this when x equals 10. So you just take and you put 10 in for x. So it'd be 2 times 10 squared plus 40 times 10 minus 72. So the y value would be, let's see, 2 times 10 squared, or negative 2 times 10 squared is negative 2 times 100. 40 times 10 is 400. And then minus 72. All right. So negative 2 times 100 is negative 200 plus 400 minus 72. Let's see. Negative 200 plus 400 is 200. 200 minus 72 would be 128. So the maximum is at 10, 128. So to answer the question, how many fish is that? That would be 128,000 fish. Because remember, our population is in thousands of fish. So if the y value is 128, then it'd be 128,000 fish. Okay. And then from the function above, what does the negative 72 mean in the context of this situation? So here's what they're asking. Is we've got our equation, negative 2x squared plus 40x minus 72. And so they're asking, what does this right here mean in terms of fish and degrees and all that stuff? Well, we've talked about this. The negative 72 is the y-intercept. And that is when x equals 0. So if we put 0 in for x, we've got negative 2 times 0 squared plus 40 times 0 minus 72. That's just going to be 0 plus 0 minus 72, so that would be y equals negative 72. So what does that mean? Well, first of all, that means where it crosses the graph up here, that's going to be at negative 72, so 0, negative 72. And it also means that when the water temperature is 0, there will be negative 72,000 fish present. So in the context of this problem, we would say when the water temperature is 0 degrees Celsius, there will be negative 72,000 fish present. Now this makes pretty much no sense, right? Because you can't have negative 72,000 fish present. But for this problem, that's exactly what it means, is when x is 0, you'd have negative 72 for your y, which means that negative 72,000 fish would be in the area. So obviously it would be 0 fish because you can't have negative 72,000, but that's kind of what it's saying. Okay, now that is using algebra. We didn't pull out a calculator once for this. We might have used a calculator, to figure out that 128, but we didn't have to bust out a graphing calculator at all to do any of this. But sometimes you will have to. And in this one, it would have been much quicker, but like I said, I wanted to make sure you understood how to do this with algebra. So if we go to Desmos, I already have it typed in here. And so here's our equation. If we wanted to find when is the fish 0, we could just graph it and find the x-intercepts. If we wanted to find the maximum number of fish, we could just find the maximum. And that would be at 10 seconds, or at 10 degrees, it would be 128,000 fish. We see here that the y-intercept is at negative 72. And then also what you might come across in some of the homework problems is they might say, well, what's happening at 12? So I just made a vertical line here when x is 12. And if you notice, if you're kind of working from left to write at 12, the fish population is actually decreasing. It was a maximum when the temperature was 10 degrees, and now it's going down because the water's getting warmer. Some fish are leaving. But, if it asks you what's the fish population at 12 degrees, you could say 120,000 fish. You can just graph it by doing x equals 12 and then finding that intersection. So, that's it for the notes for day 11 for quadratics.